So this next technique is kind of a departure from some of the other things that we've done and talked about, but our textbook called this the looking inside or look inside method. And if you take a look at this, I see here, for example, that I've got the square root of some unknown quantity, I'll just call it smiley, has to equal 6. Well, with a little bit of arithmetic background and knowledge, I know that the square root of 36 is the number 6. So by looking inside, I know whatever this thing is, it must be the value 36. So what I can do is I can say, look, this thing inside has to be 36, so let me just set it equal to 36. And in this case, it's pretty straightforward, right? If I do that, I subtract 3 from both sides, I get that the x has to be 33. So that thing inside, x is 33, and when you add 3 more, you get 36, and the square root of that is 6. So looking inside. Let's take a look at another example, one where we're squaring our quantity. And I know that if I take, it says basically I've got some quantity and I'm squaring it and I get the value 9. Well, I know that when I take 3 and I square that, I get the number 9. But I also know that if I take the number, and I should probably use parentheses here, if I take the number -3 and I square that, I get 9. So both squaring 3 and squaring -3, remember that's -3 times -3, produces an answer of 9. So there are two situations I need to consider here, right? It is either the case that x plus 12 is equal to 3, in which case when I solve by squaring I would get the 9, or it's also the case, and I'll use the word or here, that x plus 12 could be -3, again because -3 squared equals 9. So if I consider each of those cases, the first one, subtract 12 from both sides, I get that x has to equal the number -9, 10, 11, 12, -9. And in the other case, if I subtract 12 from both sides, x would have to equal the number -15. So if I plug -9 in, I get -9 plus 12 is 3, 3 squared is 9. If I plug -15 in, -15 plus 12 is -3. And when I square -3, multiply it by itself, I also get +9. So looking inside kind of gave me some insight to this problem. It turns out that x is either -9 or x is -15. The next problem that we have, and this is kind of a stretch for me actually in terms of using the looking inside method, because I actually have no idea what I'm looking inside for. It involves these problems that we've had with bases and powers, and we need to solve for a variable that's up in the power. The only tool that we have right now for dealing with things like this is that hopefully our bases are related to each other somehow. And in this case, they are related, right? Because if you look at it, one of them is 6 to the first, and 36 is equal to 6 squared. So I can get them so that I have identical bases as long as I'm willing to make this one modification. So my target base is going to be 6. So I'm going to rewrite the left-hand side, actually leave it completely alone. It's going to be x, or 6 rather, raised to the x plus 9 power. And on the other side, I know that 36 is the same thing as 6 squared. So I'm going to write this as 6 squared, but then I need to raise that to the x power. Now, on the right-hand side, when I take a base to a power and I raise that to a power, we've been down that road enough with numbers that I think we understand that that's the same thing as 6 raised to the 2x power. And over here I've got 6 to the x plus 9 power. So actually I don't think this is, I don't think I would characterize this as looking inside at all. However, now that I have identical bases here, the only way that these are going to be equal to each other truly is if the exponents are the same. Just think about it. If I have 6's and I raise them to the first power, both to the first, I get 6 is 6. If I raise both to the second power, I get 36 is 36. So those exponents need to be equal to each other. So I'm just going to set the exponents equal to each other. I need to figure out when x plus 9 is the same thing as 2x. And that's pretty simple to solve. If I take away x from both sides, I get that 9 has to simply be what x is. I take away an x from both sides. So this equation is true when x is the number 9. So what we're saying here is that 6 to the 9 plus 9 power should be the same as 36 to the 9th power, or 6 to the 18th. is equal to 36 to the 9th. So take a look at it. Definitely true, and you can verify that computationally.